Okay, take 3 of the attempting to start this lesson. Right, what we are going to take a look at specifically is the comparison between the enzyme alcohol dehydrogenase in different organisms, and I'm also going to use this as an opportunity to introduce a scientific paper and how to work with a scientific paper, especially when you're not really in that field. Usually this would start off with a review article, but because this is quite specific, I've found one that's kind of in between a review article and a fully fledged novel bit of research. So this is what we're doing, and I will put up this article onto Teams and we will hopefully be able to discuss it later. So when you find your first article, there will be a little indicator of how good it is by the number of citations. This is a fairly recent article. It's in quite a good journal, so it's from Genetics and Molecular Biology. Anything that's in Nature is kind of, there's different tiers of journals which you'll get used to. So Nature's like a really, really good journal, and if you ever manage to get something published in Nature, you have done a little bit of research or a little bit of work that people really look at as a premier piece. This is probably a second tier journal. It's still quite good. Right, the title for this is Molecular Evolution and Functional Divergence of Alcohol Dehydrogenase in Animals, Fungi and Plants. So, the first thing that I want to do is I want to show you what alcohol dehydrogenase actually does, and that way we know exactly what we're talking about going forward. Okay, so just before we start the paper, it's going to be a really good idea to go through the keywords and the chemistry that we've got for this alcohol dehydrogenase. So what this enzyme does, and this enzyme has a quaternary structure. I think it's made up of 3 polypeptides that are bound together. So what we're going to be doing is we're going to be taking an alcohol and we're going to be removing hydrogen from it. The A's is usually a good giveaway that this is an enzyme. So the alcohol itself, which we will be discussing first of all, is propanol, and we are going to have our hydroxyl group. So this is our hydroxyl group here, and what we're going to do is we're going to compare this with the secondary alcohol of propanol. So this is propan 1, all because the hydroxyl group's on carbon 1. If I'd drawn the OH on this carbon instead, it would still be propan 1 all. And I'm going to have my secondary alcohol down here, and it's a secondary alcohol because the hydroxyl group is attached to a carbon that has an attachment to 2 other carbons, or is bonded to 2 other carbons. And so this one is going to be propan 2 all. Now, the dehydrogenase is going to remove 2 protons, H positive ions. So the hydrogens, this hydrogen here, and in this example, this hydrogen here, and either one of these hydrogens here. It's going to remove 2 hydrogens. Those hydrogens are probably going to find their way onto NAD, becoming NADH. And you might remember that from higher, where we covered respiration. So you saw NAD as the hydrogen carrier in respiration. So, as we've taken 2 hydrogens away from both these examples, what we're going to be left with on this one is that oxygen has to have 2 bonds, so it's now going to form a double bond, and we are going to have this molecule here. Now this is actually no longer an alcohol because we've lost that OH and we've now got a double bonded oxygen. This one here is an aldehyde. So when you see the word aldehyde, it just means that you've got a double bonded oxygen to a carbon, and whatever. So this is the simplest example of an aldehyde that you can have. This one, on the other hand, because the oxygen is on a carbon that's bonded to other carbons, we give it a different name. So what we've got here that is a ketone. So aldehyde, the double bonded oxygen is on the end carbon. With a ketone, it's not on an end carbon. If you've got a really long hydrocarbon, it could be on any carbon apart from one of the end carbons. So, in terms of the language that we're going to be looking at, this is a hydroxyl group, that's an aldehyde, that's a ketone. It's usually not going to be propan that we're going to be talking about. It's actually probably just going to be ethanol. So ethanol is the type of alcohol made in fermentation. And ethanol can only ever be converted into an aldehyde. It can't be converted into a ketone. So whenever we're talking about ketones, we're probably not starting with ethanol as a substrate. In fact, we're definitely not starting with just ethanol as a substrate. However, with all biochemical processes, they do tend to get very complex. So your body's sometimes even capable of adding carbons on to these molecules to make other molecules. So that there is all the keywords in terms of the chemistry that we'll need for the paper. Okay, so I've had a couple of... I've read through this article, and there is a lot that, in terms of the language, you are gonna find really quite tricky. I think what I'm gonna do is I'm gonna show you the little go through what I would do, and I'm gonna leave it up to you guys whether or not you want to try and read the introduction, and we will do questions on it afterwards. So if you want, you can read the introduction, bearing in mind that you've got the little system on Word to use. So any new words, the acronym for them, and the meaning that you can look up and you can find, and you can dig your way through just the introduction. It's still, I would say it's pretty dense on quite complex material, and there's really no way I can get around it. Alcohol dehydrogenase appears to be quite a complex group of enzymes, and there seems to be a lot of it, clearly a field that is of great interest and a high level of research, and there's a lot of different classes, and there's quite a lot of nomenclature, so wording that you might find really quite difficult. What I'll do is I will put this up. I've highlighted the bit that is highlighted in the advanced higher course documents. So this is really this little bit from the course documents that takes you through, that they want you to have a bit of a grasp of this. The depth is way over the top though, and this is the best article I could find, and if you read it and you want to ask any questions, I think that's how we'll do this. So we'll base our next Q&A just on the introduction to this, how difficult we found it to read, what were the issues, and if you could all try on Teams and share your little notes for the introduction. I think people would find that helpful, and you can talk with each other about this on Teams, and I'll try and answer any questions that you pop up on Teams about it as well. But I did start by trying to go through and explain everything, and quite honestly, it was going to take a very, very long time. And it was also going to mean that I was explaining things that you really don't need to know about, and you will have to find the ability to kind of draw a line and say, I don't have time to go into all of these articles and figure out absolutely everything about this. It might be worth researching some bits and pieces, and I'll certainly research the little bits and pieces for next week as well. So I'll pop this up and I'll pop the video up. Sorry, it's both a little bit less and a lot more than I'd wanted to go into with this paper. We'll take a look at another paper that's a bit easier to get a grasp of later on, and there's going to be another paper that I'll put up that's a little bit older actually. It's from 1951, and it's to do with one of the questions that was asked. So we'll do that in the Q&A this week.